Hello, everyone. This is Qing speaking. I'm a technical support engineer in SuperMap Asia and Oceania Center. Today, I'm going to talk about the latest progress of SuperMap Cloud GIS products. So as to let you know about SuperMap Cloud Server technology, WebGIS coordinates applications, and their new features in version 11i. We will discuss these two contents, cloud native GIS technology and SuperMap WebGIS coordinates development. Let's move to the first part, cloud native GIS technology development. We put the timeline back to 10 years ago. With the continuous maturity of cloud computing related technologies and applications, SuperMap Cloud GIS technology has experienced the stage of cloud-enabled GIS of 7C version and cloud-ready GIS of 8C and 9D version. After years of accumulation and exploration, we released cloud-native GIS technology in the 10i version in 2018, entering a new stage of technological development. The initial stage of cloud-native GIS from 0 to 1 includes 3 key technologies: microservices of GIS capabilities, containerization of GIS deployment, and automation of orchestration of multiple GIS containers. This is our cloud native GIS 1.0 phase. In the 11i version of SuperMap GIS this year, we have achieved a new evolution from 1.0 to 2.0 and developed 2 key new technologies, service grid and service calculation. First, GIS service grid technology, which is oriented to the internal governance of microservices, realizes new capabilities such as service tracking and service metrics among service instances. GIS serverless computing, that is serverless GIS technology, which is based on a new computing mode, further splits and decouples GIS microservice capabilities, greatly improving the flexibility and toughness of the system at the same time. And at the technical level, GIS serverless computing technology has relatively large technical changes compared with the traditional server computing. It is mainly reflected in the serverless of various GIS capabilities, including GIS data storage and management capabilities, computing, processing, analysis, and rendering capabilities, as well as service capabilities. We can also choose the storage services and the various function computing services of cloud manufacturers to deploy and execute GIS function in a functional manner. At the same time, SuperMap also has built-in storage services and GeoFast functions in the cloud-native GIS suite. We can see that serverless GIS includes GeoFast and GeoBus. The spatial analysis and calculation capacity is functionalized, and the spatial data storage and management capacity is serviced. They decouple and cooperate with each other to jointly realize the serverless key modules in the GIS backend system. Then let's go on the second part, SuperMap WebGIS coordinates development. There are 4 technical hierarchies in SuperMap. The basic layer is web libraries. The second layer is web components. And the third layer is web templates. And the last layer is a web application. In terms of products, the first three layers are development tools. The components layer provides view or React components, and the templates layer created from components provides ready-to-use industry templates. The layer for web applications generated by development tools provides code-free applications and codeless applications, and also the mapping applications, which we will discuss in the following content. So let's firstly have a look at what can codeless web applications do. Then we are going to talk about the new features of them. SuperMap provides rich codeless web applications covering various scenarios. The mapping applications such as database and Map Studio for 2D mapping, and the IRs for 3D scene, and the code-free codeless applications such as data insights is to mining data. GPA is to build workflow of processing data, and map dashboard making. SuperMap provides easy-to-use mapping, data editing, and thematic mapping capabilities, and has built in a variety of rich base maps and map operation tools to help users quickly make and share web maps. We can make different kinds of industry maps, such as the landslide range map, station diagram, flat route map, and others. We can also view the 3D scenes and do 3D spatial analysis online. We also provide code-free data insight that can analyze data online, combine charts and maps to mine data value. For example, the spatial distribution of COVID-19 in Beijing and the interaction of charts are used to analyze the development trend of Beijing epidemic. Reports can then be shared via QR codes or links. You can also export to PDF or Word document. We can also use the processing automation tool to freely combine the operators of data processing and analysis through drag and drop modeling, so as to realize the automatic workflow of spatial data processing and analysis process. We can use code-free and interactive visualization methods to quickly create location-based analysis applications to help make decisions, analysis, change trends, and real-time monitoring. The web applications can be seamless collaboration. The results of 2D maps and 3D scenes can be accessed to map dashboard. And the map made by database can also be accessed to data insights. Then let's talk about the new features of SuperMap WebGIS codeless mapping. Map dashboard, Map Studio. SuperMap has improved the basic mapping and the thematic mapping of Map Studio. We can see the symbol, color, size, transparency, and other forms of a single layer to mapping. On the other hand, for the segmentation method of thematic style, 6 algorithms such as equal interval are added to make the data display more reasonable. Taking the mapping of earthquake distribution in China as an example, we only need to render one layer with multiple styles. The style of symbols indicates earthquake measurement methods. The size of symbols indicates earthquake grade, and the color of symbols indicates earthquake depth. And you can also turn on the text to display the earthquake date. Compared with the traditional mapping method, making such a map requires 4 layers. In contrast, the new semantic mapping is more efficient and has better rendering performance. For reading data, it can be stretched to 3D model by one click, and there is no need to generate a new layer. At the same time, it supports semantic mapping of model color and height. The previous version of Map Studio can load and view the image service layer published by a server. In version 11i, the basic elements of points, lines, and regions can be marked on the image layer. The attributes of the marked elements can be set and viewed. In addition, the marked elements can be downloaded, and the map can be shared with multiple persons. At the same time, Map Studio also optimizes the UI interfaces in English and Japanese. Let's look at this case. This is a flood warning map of areas around Tokyo, Japan. Map Studio is used to visualize the flooded area after the flood, to inform the public of the possible flooded area and the degree, as well as the nearby emergency shelters. Then let's move to the third part, the new feature of SuperMap Webgis coordinates applications. And the first one is map dashboards. There are more than 10 new industry templates to speed up the construction of coordinates applications. Meanwhile, the template management page classifies more than 10 industries, which is convenient for users to choose. In the future, industry templates will continue to increase and try to cover the subdivisions of various industries so that they can be ready to use. And the new video enhancement component is added to Map Dashboard, supports accessing mainstream video equipment. The video can be used as the background of Map Dashboard. Compared with traditional video components, we provide some basic interactive functions, such as overlay monitoring points, click query, and others, which can be used in multiple industry scenarios, such as smart parks. In order to meet users' in-depth application needs, an important module has been added to the 11i version of Map Studio or Map Dashboard. It is Coordinates Editor. The function requires developers to know JavaScript. When the depth requirements cannot be met through drag and drop construction, they can expand the development online, and the developed code will be saved in real time. Using the coordinates editor, we can customize any styles of page elements. We also provide complete interactive events and generate event codes with one click so as to help developers quickly code. In addition, the coordinates editor also provides easy-to-use functions such as complete lifecycle management, the object method, or property intelligent prompt. No need to refresh the page, and the code can be executed online quickly, and console output logs for debugging. You can simply understand it as this is a web Visual Studio Code editor. Besides, the material library or map dashboard, such as commonly used titles, background pictures, border styles, has been updated. Now the material library is more abundant, and the production and the application will be handier. And we support international font customization. This is a map dashboard for traffic accidents in Japan in 2019 and 2020. The details of the accidents in these 2 years can be viewed through slide playback. You can use the keyboard to operate the application, and it supports mobile terminal viewing at the same time. Then let's talk about GPA. Firstly, what is GPA? It is geoprocessing automation, which can quickly build GIS business model by dragging and concatenating operators in a view interface so as to realize automatic running of tasks. GPA is provided by SuperMap iDesktop X and SuperMap iServer, and SuperMap component libraries provide custom development support so as to meet more complex applications. There are 4 features have been optimized in 11i version. The GPA is a codeless application, and it has multiple operators to construct the processing flow, and it supports for developing custom tools by Java or Python. And in 11i version, we also greatly improve the performance of GPA, and programmability supports more complex business scenarios. With GPA, you can easily build data processing flow by dragging operators in a visual interface and run the workflow by one click. There are more than 900 operators provided in GPA, help you construct multiple industry analysis models easily. And you can develop custom tools by Java, Scala, or Python for deep applications. We also optimize the processing performance through memory caching mechanism based on distributed geographic processing. That is, we don't store intermediate results to avoid data redundancy, so as to greatly improve the analysis performance. We did a test, that is, to detect net use change through different iterations. The result shows that the new memory caching mechanism has greatly saved processing time, and the more complex the analysis process, the more obvious the performance improvement. Then let's talk about Cpa programmability. We can change the variability, inline variable substitution, and iterative loop and other methods to simplify modeling process and support for constructing more complex business models. Take this data cleaner model as an example. The workflow is to import shape files and process them, and then export the results to shape file again. For the process with repeated operations, we can simplify the model by variability, iterative loop, and inline variable substitution to achieve batch importing, processing, and exporting. In addition, GPA processing supports autonomous control execution. You can cancel or start execution at any nodes to check the results or modify parameters to avoid repeated execution so as to save the modeling time. Then let's move to the last part, the new features of SuperMap WebGIS coordinate development tools. We provide rich coordinate applications for users, but we also provide full code development libraries to support more complex business applications. And in 11i version, we also optimize ES modules to realize the construction of the whole library on demand, which greatly reduced the package size after on-demand import. Taking the natural resources map dashboard template as an example, the package size is reduced by about 19%. And we fully optimize the naming of all APIs. Taking SuperMap client for leaflet as an example, we have simplified the naming, added usage instructions, and supported on-demand import. And this change will not affect the previous programming. And as I have mentioned, the coordinates application, our new video enhancement components are also synchronized to the open source library for further development. Then let's make a summary of coordinates web development. With coordinates applications, we can make maps easier, and the coordinates applications are more powerful, and full code development libraries are more complete to support more application scenarios. At the same time, the new features of coordinates applications are synchronized on the SuperMap Online. There are no functional restrictions, and you can try it for free. And that's all of my presentation. Thank you.